Hello and welcome to the Daily Space for today, December 27th, 2018. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. We have a busy day today. We have a variety of news coming to us from not just the solar system, but the universe at large, and even a little bit from here on the planet Earth. Later on today, we're going to have a launch of a Soyuz 2.1A frigate, Canopus 5. This is a Russian Earth observation satellite that is used for real-time monitoring of natural and man-made, things and stuff that occur on the surface of the planet. This is the kind of satellite that you use when you're trying to understand what's going on with the Krakatoa Ankh volcano, when you're trying to keep up with all the things happening out in Siberia as various icy clasts melt, leaving craters. This is the kind of satellite that's becoming more and more important in our changing world. But before that can happen, let's take a look at what's going on our own planets, or at least coming from our own world's astronomers as they look at the universe beyond. In today's first story, we have a tale of solar flares going nuts. This is astronomy coming to us from the University of Warwick, where astronomers have seen one of the largest ever coronal mass ejections from another star in another part of our galaxy. This massive outburst was so massive in X-rays and other high-energy forms of light that is believed to have perturbed the debris disk of material around this young star. This is the material that is in the process of forming planets. This may have, in fact, changed how the planets themselves form. If any of the planets were large enough that life might have started, that life is probably not there anymore. This UV and X-ray radiation, this is the stuff of planetary sterilization, and we caught it all in the act of happening. This is going to be one more bit of information on what stars you may not want to look for life around, or at least wait a bit for that life to have had a chance to start all over again. Anyways, the universe is trying to kill us, and in this case, it's also trying to kill life on other worlds. Now, coming a bit closer to home, we have a tale of radar astronomy. This is a series of radar returns from the asteroid 2003 SD220. These images were taken when this object was about 2.8 million miles or 4.5 million kilometers away from the Earth. This is a bit more than 10 times the Earth-Moon distance. This particular asteroid was discovered in September of 2003 by astronomers working at Lowell Observatory. This is what we refer to as a near-Earth object, an object whose orbit gets it a bit closer to Earth than sometimes may seem comfortable, but at more than 10 times Earth-Moon separations, we're good. This particular rock, this is as close as it's been in the past 400 years and as close as it will be for a mighty long time. It will come a bit closer in 2070, but in general, it does luckily stay further away from the planet Earth. This particular set of observations, this allows us to to keep understanding all the different shapes, forms, structures that asteroids come in. Now, unfortunately, the survey that was able to find this, the Lowell Observatory Near-Earth Object Search, is one that's no longer in operation, but we are keeping tabs on the objects that it was able to find. I see in chat that people are comparing this to a sea lion. I personally see a hippopotamus rising up out of the water. Asteroids are one of those chances where we get to play with our own human pareidolia and look for shapes, not in the clouds, but in the rocks. Not much to say other than cool. Its radar returns on an asteroid. Nothing particularly striking here. Just another, well, in this case, hippo-shaped object orbiting through our solar system. Now, speaking of things moving through our solar system, this is an image of a star that was occulted by the object Ultima Thule. Several months ago, a series of astronomers working with the New Horizons spacecraft put themselves along a particular path on the planet Earth, where astronomers would be able to see that little tiny glob of ice passing in front of a background star. This would give us an opportunity to see just what its shape is, because different people on different paths along that shadow on the Earth would see this lineup of objects in slightly different ways. The way to think of it is, returning to my constant use of random objects on my desk, if we have our Ultima Thule Marvin the Martian and a background star, as Marvin goes across from one perspective, he won't completely block it out, and you'll get one set of timings as he passes across. Now, if he passes across from higher up, he will block out more of the star's light, and you'll get a longer timing. By adding up all these different events, and you can even have a background object that is weirdly shaped, or rather a foreground object that's weirdly shaped. And as you measure all these different timings from all these different places along the path, you can start to build up a shape model. Now, the other thing that you can do is look at our object and measure the light from it. When we're seeing the biggest part of it, we'll see the most light. When we're seeing the smallest part of it, we'll see the least light. And depending on the mottled coloration on the object, we'll also get changes in reflectivity. Now, the thing that's super confusing about Ultima Thule is this object doesn't appear to change in brightness at all. Astronomers have been following its brightness changes, planetary scientists have been following its brightness changes, and its brightness changes are none. This seems to indicate that we are either looking at a nice, perfect sphere that has no color variations, that we're looking at something that is lined up perfectly so that as it rotates, the area of what we're seeing never changes and it's the same color everywhere. Or somehow it's just not rotating relative to the Earth. There are weird ways to explain this. You could surround it with a cloud of moonlets that just happen to have their sum total brightness over time, where each moonlet is changing, add up to no change at all. All these things are weird. These aren't the things that normally happen or are expected at all. So, people planning out the path of the New Horizons spacecraft as it passes past Ultima Thule are planning for an ever closer encounter. And we see no moons. We see nothing that we could worry about. It's just kind of mysterious. And we like mysteries. But they make reporting on what to expect kind of difficult. And we simply know there will be seriously good science coming out of this mission. Now, this seriously good science is going to be coming out of this mission on December 31st and January 1st. So any of you who want to, like me, keep up with what's going on, you're going to have to cancel all your New Year's plans. What we're looking at right now is from roughly 8 p.m. to just past midnight on December 31st. All times are Eastern. We are going to be having a combination of media briefings and the encounter itself happening at roughly midnight Eastern time. We then expect to be getting the first images in around 10 a.m. Eastern. That's 9 a.m. Central on January 1. So that means yours truly will be getting up earlier than I like to do ever, and will be streaming late on December 31st and January 1st. Now, it wasn't that the spacecraft had to choose to do it on this particular day. It's that they purposefully chose to do it. Now, one of the things that you may have noticed over the years is that NASA over and over has had mission encounters that occur on the 4th of July, on New Year's, on Christmas Eve, on Thanksgiving Day. All of these events are scheduled this way. Slight variations in when rockets are fired, slight variations in paths that are chosen can all change the encounter times just enough to have things occur during normal working hours, or to have them occur on weekends or on evenings. And there is something appearing to breathe on my screen right now. What is my extension doing? I do not know. Apologies for whatever on my screen is currently appearing to breathe above the Instagram. That was kind of crazy. I'm guessing that was some kind of a notification I just spotted. Anyways, okay, I'm going to stop being distracted by my own notifications and say, choices were made to ruin our holidays as completely as possible for science. This is done to essentially allow you, as many of you as you want, to come and take in all of the science, to experience it as much as possible, to not be tied down to your work desk where, well, YouTube might not be allowed, where NASA TV might not be allowed. So scientists the world over, and science communicators and journalists, we are giving up our holidays that more of you might experience more science. I hope you appreciate it. And I kind of wish they'd take out more random Saturdays and fewer federal holidays. Anyways, that's what's up and that's what's going on. And if you like this kind of special event, 2019 is going to be an entire year of special events. There are a whole variety of anniversaries that we're going to be celebrating, from the International Astronomical Union hitting its 100th birthday to the 50th anniversary of the moon landing to, well, a whole bunch of other stuff as well, including anniversaries of Kepler's discovery of various of the planetary orbit laws. It's going to be science anniversary after science anniversary, and all of you are invited to join us in these celebrations as we celebrate 100 years of the International Astronomical Union and all of us sharing one sky, living under one sky. We will be doing what we can, and we will be telling you when cool stuff is coming up. Hey, thank you, Bill Nash, for the 1,000 bits. Thank you so very much. And speaking of bits, I want to thank all of you who participated in our 40 Hours of Science for Science Hangout-a-thon last weekend. We were able to raise almost $22,000 in those 40 hours and in the days leading up to it. We are still continuing to bring in funds through the end of the year. I am so grateful for the additional more than $6,000 that has come in, nearly $7,000 that has come in since Christmas Eve. Because of you, we have almost 3 months worth of part-time funding for our staff, which means that we're going to be tightening our belts a whole lot. But we're going to keep the science going. As I said, we are going to continue to taking donations. Streamlabs.com/CosmoQuestX is where we would ask you to donate. If you stay tuned, somewhere in the mix of all that ultimate Thule excitement, we are going to be launching a new version of the CosmoQuest website. And we're going to be keeping the science coming. So stay tuned, Glacier Lakes, perhaps even a preview of Ceres and Bennu and all the other worlds we invite you to help us explore. The science is coming. Thank you so much, Convergent Coefficient, for the $100. Thank you. That matters so much. We are so close to hitting the halfway mark on our goal. So we are now continuing our wait for a rocket launch over in the Soviet Union. We are showing 44 minutes on the countdown clock. And I'm not going to try and do real-time translations again. My Russian is just not that good. But I will take your questions while we have this going on in the background. So if you have any questions about today's top news stories or anything else related to space or astronomy, I am here to do what I can to answer those questions. Looking over at the chat, I know they said they went up. They lied, Annie, on when they said they were going up. So, yes, this is the Soyuz 2.1 frigate, Canopus 5. The information I have on it, and Binary Ablaze is going to know more about it than I am. It says that this is launching from Siberia, and this is a real-time monitoring satellite for looking at natural and man-made emergencies, detecting forest fires, and monitoring land and water resources. So Hanny is asking, do we know the asteroid's composition? Yes, I don't, however. Hold on, let me see if I can get that answer for you quickly. So many windows open. So I can tell you the spatial resolution on the images was 12 feet per pixel. It is not telling me the composition. Let me see what I can do by Googling the asteroid. Most asteroids are what we call carbonaceous chondrites. These are just like generic rock. It's part of the Atlan group. There is a Wikipedia page about it. Let me see if I can find composition. There is an angry puppy in the background. Yeah, I'm not seeing anything on what its composition is quickly. So sorry that I can't answer that. Okay, looking for the invites. Is there a place on Russia where most rocket launches are carried out, like Cape Canaveral? Yes, there are 2 or 3 different places. I know of 2. The first is Baikonur, which is south of Moscow by several hours by train. And then the other is where we're looking at launching from today. This is the Vostochny Cosmodrome in Siberia. I don't know the difference in these facilities. They are further north than most of the facilities that get used by the United States and the European Space Agency. These particularly northern positions haven't hampered the Soviet Union or Russia at all in their explorations, however. Larry is asking, I know why a rocket needs a big thingy right beside it, but why the towers 100 meters beside it or more? So you may have noticed both in some of the background images on this particular launch, as well as for launches down in Cape Canaveral, that you have the central launch pad and then around it these 4 different towers poking up into the air. Those are actually lightning abatement in many cases, and they do have other instrumentation on them, but you really don't want your rocket struck by lightning. So we are building these sets of towers around the central launch spire. I'm sorry, I need to go see why there's an angry puppy in the background. Please stand by. I will give you Russian audio of this upcoming launch, and then I will be here to answer your questions. Assuming I don't knock over my green screen. Let's see if I can do that. Nope, that did nothing. Okay, I will return.
Вот малые космические аппараты на ваших экранах.
Это с близкого расстояния солнечной батареи. Очень красивые.
И вот вы видите аббревиатура ECM. Это изготовитель контейнеров для выброса вот этих космических
пусковое
аппаратов.
устройство.
Да,
пусковое устройство.
Все это закрывается головным обтекателем и уже становится в совокупности космической головной частью, которая тоже присоединяется к ракете.
This is the angry puppy. She was yapping because she has her treat, but she also wanted Eddie's treat. Eddie is my other dog. Okay, so yes, we have a fluffy puppy. And the fluffy puppy now wants to stay. Okay, hopefully she'll be a little bit quieter now. So Henny's Wardrobe, there are agreements that people can launch from a variety of different places, or at least land. We have lots of agreements for landing. But one of the real issues is we generally, there's a lot of proprietary stuff going on. And so it's more a matter of we don't want other people to know what we're doing. And there's also the shipping issue. If you're constructing your rocket in the United States, it's hard enough to get things from the East Coast to the West Coast. Trying to get stuff to another country is even more difficult. So between here in the United States, we refer to it as ITAR restrictions, where a lot of the technology isn't allowed into foreign countries. Between restrictions, between difficulty, it's easier to just throw a little bit more fuel on the spacecraft. Other questions? I'm glad that you love the fluffy puppy. Yeah, poor Eddie. That is the ongoing, thing. DPI 209, I don't know, but the electrons are super tiny, so they're easier to ship if they are getting shipped. Hi, why are you back? The puppy is back. I have a puppy beside me now. So do we have any more questions out there in the chat? I don't know anything spacetv.net. You guys are asking all the questions I don't know answers to. I have to admit, in all of the astronomy conferences I've been to, I've never heard about a Russian space telescope. Actually, I did hear a little bit. I think it was a Chinese space telescope that Daniel Fisher was writing about. The person to ask would be Daniel Fisher. So the Russians have a radio telescope on orbit. Let's see what else I can find. Sorry, I ended up on a massive list of these things. So invisible light, we have Hubble, MOST, Bright, which is Austria, Canada, Poland. Neosat, which is Canada and Germany. Astrosat, which is India. So they don't have anything that's visible light. So I don't know. Sorry about that. As I said, Daniel Fisher would be the person to ask. So Ambius is saying, I've been thinking a lot about the environment effects of launches lately. How bad is it really, and is there a way to reduce it other than an entirely new method of launching? Yeah, this is something you don't want to think about too much if you like yourself, because we probably can't do anything to change it, and the Christmas tree behind that woman is insane. Sorry about that. Literally distracted by shiny, blinking things. I was at a new commercial space conference back in, I believe, 2010 or 11, where there was someone who does planetary atmospheres who ran some calculations, and once we get to the point that we're launching about a rocket a day, which we're not too far away from right now, because they put various greenhouse gases, and ozone can be a greenhouse gas depending on where you put it, because of where they're putting different gases directly into the atmosphere, they do have a rather significant effect, and it's a problem. Yeah, it's a problem. I'm not quite sure why we're exterminating eggs. Oh, because it looks like a Dalek. Yeah, I can get behind that. I can get behind that. Unfortunately, Fenric, I don't think we're going to have a nuclear propulsion renaissance. As near as we can tell, there just isn't a way to channel the energy to get the kinds of delta V's that we really need. There's lots of different ways to create power. Yeah, it is depressing, Ambius. Mag sails are great once you're in space. What we do need is that space elevator. Space elevator is going to be the ultimate in green ways to get off the surface of the planet. And ideally, we'll have space elevators off of both the African continent and out of Central America, and South America, I guess, is where the equator crosses. So if we can get one on both the eastern and western side of the planet, it would be glorious. But we still are a long way from developing the kind of carbon fiber nanotubes that can give us the strength we need. Yeah, we do need an elven rope. That would help. Or to be able to spiderweb. I mean, this is crazy, but spiderweb is still one of the strongest substances we know about. We just need to figure out how to make it without enslaving spiders. Yeah. So Bill Nash, space elevators are completely viable once we figure out how to generate the material needed in a cost-effective way. We can, there's a lot of money getting spent on carbon nanotube and spider web research. And those are two things you would not expect to say in the same thing. We know that individual strands of both materials have the potential to get us to the tensile strengths we need. We just don't know how to bundle things correctly. So we're working on it. We're working on it. Yeah, no, it isn't there yet, but I'm hoping. I'm hoping. There are more problems than just the material science, Ambius. This is the kind of thing where once you get a space elevator in place, you are knocking out a huge swath of usable orbits above the planet Earth. So a good space elevator if this is our planet Earth, we have our space sorry, I should be on camera. We have our space elevator at geosynchronous, so that as the Earth rotates, I don't mean to be moving the Earth, as the Earth rotates, wow, I can totally not do this. Okay, you're just going to have to imagine with me. As the Earth rotates, the space elevator's point stays over the exact same place on the planet Earth. To counterbalance that, so that you have the center of mass of your space elevator that's going from extremely far away all the way down to the surface, to make sure its center of mass is at geosynchronous orbit, it's going to need some sort of a counterweight extending up. This means that you can't have satellites in any of the lower orbits that cross the path of the space elevator if you don't want to have to steer them constantly. So that's going to knock out a whole swath of orbits that can be used. That's a problem. These are going to be way too small to cause eclipses, Hanny. Satellites cross the sun all the time. There's some amazing images out there of the International Space Station in front of the sun. We just don't notice it with our eyeballs. Yeah, we're disillusioned. We're getting so close. I'd love it if we could at least hit the 30,000 mark. I mean, ideally, I'd like to get to 60,000, but we still have a few more days to raise funding. So space elevators are possible. We don't have the technology yet. They do devastating things to our ability to take advantage of lower orbits. And some spacecraft require lower orbits. So basically, they're a big pain in the expletive. But if that's what it takes to not be polluting our planet with constant launches. Other things that are being considered are space slingshots. This is where you have rotating things that dip down through the atmosphere, nominally being able to latch on to gliders or airplanes and then swing them up to higher orbits. Kim Stanley Robinson does a really good job exploring a lot of these concepts in his books. I believe it's his 2049 or 2349. He has a book that has a 4-digit title. That book explores these ideas really well, and I'd encourage you to read it. So Ambius is saying, even if we did have the science to make them suddenly tomorrow, how will we be able to clear the already existing orbits? That's part of the problem. That's part of the problem. So Hanny, I don't actually know. Laser beams. Laser beams are awesome. Not fully capable of launching things into space. We are able to launch extraordinarily small masses using rail guns, which uses up a whole lot of electricity, but is nonetheless super cool. So alternative ways to get things into space. Yeah. So that's what I've got for today. I'm going to hang up now. I suspect that Annie is going to take over with this rocket launch. Actually, Annie, can you confirm in the chat that you're going to take over for the rocket launch? Thank you, Ed Thompson, so much for the 150 bits. Thank you. The bits really matter more than ever this year. Bits equal feeding Annie. So for those of you who don't know why we're fundraising so hard, and I will totally give you the URL I'm on. Paranor's got it for you. So we've been funded by NASA since 2012, and we will continue to be funded until midnight, December 31st. And then our funding goes away. We were warned a few months ago that cost overruns on the James Webb Space Telescope, that changes to policies might affect our funding, and it actually zeroed our funding. And we are positioned better than ever to do an amazing job for you. Our project is now part of the Planetary Science Institute, working in collaboration with Youngstown State University. And the Planetary Science Institute is a place with over 100 PhD researchers that we can collaborate with. I haven't worked somewhere with this many PhDs in astronomy and space science since I worked at Harvard. And now that we have this amazing brand new institute to work from, well, I put in my resignation to switch institutes on a Tuesday. The new institute was going to talk to NASA about transferring the funding on Friday, but everything was canceled on a Thursday. So we're now trying to raise the funding necessary to keep the lights on, to pay people part-time for a few months while we seek new big grants to keep bringing you the science and the opportunities to learn. If you can help, we will do everything we can to make you proud. And my way of contributing is I'm not going to take 1 cent of these donations to pay my salary. That's all going to our staff. The OSIRIS-REx mission is paying our servers, and I'm going to pay myself off of grants that I'm able to bring in. So help if you can. Now, I think that YouTube will have the Russian launch on it. It says live. It was talking about countdowns earlier and showing the launch pad. So you're just going to have to kind of pray while you watch that you'll understand things. Oh, it's not live. Dang it. Dang it. Okay. It said live. It's lying. It's lying. Okay, I'm sorry about that. I am showing you feed that I thought was live because it says live and it is not live. I'm going to kill that feed. I'm going to kill that feed. Sorry, Annie. So we have no idea how we're going to potentially bring you the live launch of Soyuz 2.1 Frigate Canopus 5 launch. But it's going to nominally happen at some point, maybe. 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 I'm glad you found it nice. So, while there are the perfect number of viewers, there are 42 of you. You are the answer. I'm going to say thank you all for being here. We do this for you. I'm going to keep bringing you the daily space Monday through Friday. We will be here New Year's Day because New Horizons, because Ultima Thule. So stay tuned. We will bring you live rocket launches, and I'm going to be doing a whole bunch of website design, and I'm going to be doing some of that website design for our new CosmoQuest site right here on stream. So if you haven't already, give our channel a follow so that you can find out and get that notification every time we go live. We are sustained by you. Every bit, every subscription, every donation through the new year matters. Your donations are tax deductible through the Planetary Science Institute, a 501c3 dedicated to exploring our solar system. So please, if you can, give. Thank you, and wherever you are in the world, have a fabulous morning, evening, or afternoon, and remember, go outside and look up. Bye-bye.